Okay, good evening everybody and welcome to Intuit Circle webinar. Let me quickly introduce you all to Intuit Circles. Intuit Circle is an ecosystem to facilitate startups for business growth. Intuit Circle has 4 offerings to startups. First one is Connect Startup to Startup. We have now more than 2,000 startups registered with Intuit Circles, and startups can leverage other startups to get connected with. Second offering is support startups by enabling financial fitness using QuickBooks for accounting. Third is providing a platform for building application for small business customer. As of now, Intuit has more than 4 million customer base. And lastly, the mentoring on technical, financial, and business topics using webinar. With that, let me welcome Bala Dutt, who is the presenter today on the topic fine-grained access control for your application. And a quick note that you are in mute mode at this moment, and in case of you have any questions, please type it in your questions tab, and we will be answering post session. Thank you. Over to you, Bala.
Thank you, Manish. Okay, so the topic today that we will be discussing is fine-grained access control for your applications. And I am Bala Dutt. This is a little bit about me. I have built web servers, app servers in my past. I have built online applications of large scale. And of late, I have been busy working in the area of protecting resources that users entrust Intuit with through the applications of Intuit. So I have been working in Auth area and have been trying to apply ABAC and such technologies to Intuit's resources. This is the invite that you would have seen, and basically we are going to talk about access control, and I'll introduce the terminology in the beginning, but the trigger for this topic was that we often build applications without thinking of access control, and we always apply it as a after effect, and that creates a lot of problems. I would like to share some of the problems and then present a solution which will help us create applications that will be future proof as far as the evolution of access control happens with the application. So this is the agenda. I would first talk about why access control has become important. And if you would have noticed in last few years, there are a lot of startups solving for access control and identity areas. And there have been equal number of increase in violations and issues, and we'll talk about them. Once we understand a little bit about this area, the demands of this domain, we would talk about resource-centric view, which I think can help in creating a easy to manage access control products. And then we'll talk about RBAC, role-based access control, and we'll end up with attribute-based access control, which solves for the limitations of Auerbach and which solves for the very complex demands of today's access control. Okay, so let me get two terms which we would use here a lot. So these are often confused. So we talk about authentication and authorization in same breath, but these are two very different things, and there is a lot happening in both of these areas. So the first area is the area of authentication, where the identity of a person is proved, and the way it is proved is that the subject or the person would basically provide some evidence, which could be something that the person knows or something that the person has. And for example, passwords is something that the person knows, and fingerprint is something that the person has, or a device that the person has. That evidence is provided to the identity provider, and identity provider basically then establishes the identity of the person. So it just says who you are, and that's where authentication stops. And this is an area where a lot of interesting things are happening. There are ways to ascertain the identity, things like multi-factor authentication, and things like passwordless systems are all new things that are happening in this area. It's a very exciting area. But I'm more interested in what happens after an identity has been proved. And that is the area of authorization, where the system decides what you can do once your identity has been proven. So in short, these things are called as auth-n and auth-z. In this session, we are going to talk about auth-z. So a real world analogy to think about auth-z is if we would like to look at a building access control. Now, building has a lot of areas. Some of the areas are available to visitors, some of the areas are available to employees, and some areas are only available to very small set of people, admins, etc. All these are protected by devices that look for piece of information, different piece of information. So for example, at the entrance of the building, a simple device that looks at your card and lets you go would be there. There would be specific devices with probably password and card that might be on some doors, and then there could be devices that look at biometrics. And these devices, even though they get this information, they would still have some more logic to decide whether a particular person should be allowed inside or not. Now, couple of interesting things from this analogy is that you would see that there are many things to protect, and one particular user might get access to many things depending on what role that user has. In software world, this becomes a lot more complicated because every piece of functionality, every piece of data is to be protected, and there can be many roles that can be custom defined. So this problem only gets magnified in the software world. But this is a real world analogy where you are trying to protect access to certain places in the building. Okay, so let's look at a code that usually you would find in the products. If your product has sufficiently grown and evolved and it serves a lot of use cases, you would see that there are a lot of ifs inside the product. So somewhere it says if the product is ABC, flavor is simple, user's role is admin, and the permission that user has says allow read of all transaction, if the billing status is active, and things like if country is this, and whether a particular feature like GST, which only makes sense for India, let's say, is enabled, then allow access. And these ifs are spread across the code, across different systems. What is the problem with this? there are few problems. So one is it is inefficient, because you would see that in a single request multiple times we would check these conditions, and many times you would do a lot of work. For example, make API calls, go and fetch data from database, and then realize that, oh, this data should not be sent to the user, and this results in wasted work. The second problem with this is that because this logic is spread inside code, it is mixed with business logic. There is always a feeling that there is a loophole, and there is no confidence that the system is well protected. And you could make your system very hard, where you might start preventing valid users from getting access, or you might end up making system easy on user experience but might allow invalid users or not allowed users to access certain features. Also, it's costly for use cases where PM wants to create a new role. If your code has this if user role condition throughout, and if you have to introduce a new role, you have to go around at all the places, add another condition, release the software. You have to do a lot of testing because you have now added a new condition, and it takes the speed at which you can release new roles is the speed at which you do your code release or your product release. It is also one of the Gartner reports. It showed that 20% to 40% of programming code that we write in non-trivial applications, it is related to authorization. And this is what we also notice in a lot of large code-based products. So this is one area that eats a lot of money, and it is something that has been done in traditional ways, and we have not really evolved a lot. And that's why I am passionate about this area, and we'll talk about how we can make this better. Now, we also have seen a lot of access control leaks. So we see some of the data that got leaked. For example, Cambridge Analytica scandal. We know the app was collecting more information than it was supposed to collect. So it basically was supposed to collect only data pertaining to the people who have agreed to take the survey, but it also took data of people who were in that user's social network. Even today, we would see that there are a lot of APIs every week that get listed with vulnerabilities which are related, which are similar. For example, very recently, the Groups API of Facebook, it was abused by around 100 partners, where the data of a user was allowed to be accessed by the app when the group admin gave access and individual users didn't. There are other issues like Amazon Ring doorbell, while doing setup, was sending Wi-Fi passwords in plain, and it could be sniffed, and Wi-Fi passwords could be leaked. There is also a huge list, a class of vulnerabilities called as BOLA, broken object level authorization, which companies like Uber, Verizon, Facebook, and T-Mobile have been seeing. So in brief, what does BOLA? BOLA is a very simple issue. So consider, for example, Uber, right? Uber, what kind of domain entities Uber has? It has rider and user. Basically, it has riders and driver as users. It has trips, it has receipts, it has text conversations between driver and rider, which are stored as message entities, and it has which type of vehicle, car, scooter, bike, etc. Let's say you have an API which is used to fetch trips, and it looks like something like this: /API/trip/7891. Now, BOLA attack basically, in BOLA attack, the hacker basically tries to fetch the trips by incrementing this trip ID, or finding a pattern and trying to find the next trip ID, and it tries to get it. And you'll be surprised that in a lot of these cases, the hackers succeeded. So these things were protected just by the obscurity of the ID and not really at the object level. Now, for the use cases that we are going to discuss, it's good to imagine an app. So imagine that you are building an invoice application which lets people, users create invoices and send them to customers. It's a multi-user application. You have multiple people who are salespersons who actually log into application and create invoices. And then there is a sales manager who basically manages these salespersons. So keep this application in mind when we talk about OG use cases. So when you first build this application, you basically provide access to specific functionality. You say that, okay, the sales manager can access invoices functionality, which is the whole set of functionality, which includes all invoices for all people, and do any operation with the invoice. Then you realize that, okay, I have multiple branches. I need to create managers, have managers for each of the branches. And you say that, okay, the Bangalore manager can only see Bangalore invoices, etc. So you want to restrict based on specific data. You want to partition your whole invoice set into subsets, and only Bangalore manager gets to see only Bangalore's invoices. Then it is possible that one particular instance of an invoice might be might be delegated to another user, and you might like to allow that kind of access. Now, when you send an invoice to a customer in email, customer would like to see an online copy of that. In that case, customer does not sign in into your system, but gets to see that particular invoice, and that is because of the link that was sent to the customer. When you start having multiple users, the sales managers would start defining roles, and they would start assigning permissions to those roles, and then assign those roles to end users. And that way they get much more finer control of access to the application. Now, let's say you have been using this application and you have an issue. You call customer support, and customer support, to help you, wants access to this data of yours. Customer support should be given access only in that session. This is basically temporary access that's given for a period of, let's say, 10 or 15 minutes, the duration of the call. So that's another kind of authorization that has to be performed. The next one is, let's say you integrate with third-party application, and that third-party application is white labeled inside your product, but you want to make sure that only the application or parts of application are accessible to the right person, depending on the role. There is also the access of the functionality based on well-established protocols like OAuth, which allow external applications and non-browser based internal applications to access functionality. So these are all the cases that authorization has to solve for as your application becomes as your application evolves. So let's talk about how would you do it, how the traditional way to do it. And this is also evident in some of the standard APIs. So if you look at J2E, right, you would see there is API like is user in role, which takes a role and returns a boolean, and you would see that your code is spread with this kind of checks. And I think the verse is actually looking at get users principle and making decisions based on the user's principle. Spring method security, which is slightly new, it has an annotation, which is nice, but it still talks about role as an input to that. And I'll talk about why I think role is a problem. If you look at .NET's public API, it also has authorized attributes, and it takes roles or users as input and wants you to make decisions based on roles and users. Now, there are two problems if you did like this. If you protected your piece of code using roles, there are two problems. One is that at some point, if you want to give feature access to your end users to create roles, custom roles, and which are collection of permissions, then your code will not know about roles. So this thing will fail when your end users are defining the roles. The second problem is, even when the developer or the internal product team defines a role, one has to go and change the code. Which is, like I said, it drastically reduces your speed. So the advice here is, do not use roles in code. Although we have APIs that look like this, I think we have learned it that using roles in code like this makes your code tightly coupled, and it doesn't let you evolve and serve the use cases. And second thing is, you are actually embedding security decision here in the code, which is also a problem. So you should delay the security decision as much as possible, and we'll see what it means. So the crux of this slide is that do not use roles in code, even when you have standard APIs suggesting that you do. So what should be done? What we are advocating is that we should take a resource-centric view. Now here is a standard English definition of resource, which I'll not get into. But from the perspective of authorization, resource is defined as the object that we are trying to protect. And what could be a resource? It could be anything. It could be a data element, a component of software. It could be an entity. It could be a document. And a resource can have resource instances. So for example, if I say that invoice is a resource, each of the invoice instances are resource instances. We're also saying that resources can be hierarchical. So if your application has a sales functionality, and inside that you have invoices as the resource, if someone gets permission to access sales functionality, they also get access to resources inside it, which are invoices. So the hierarchy, the parent-child relationship between resources, is enforced as if you have access to parent, you also have access to the children. A resource can have multiple actions. Here are some examples of them. It doesn't have to be limited to CRUD. For example, invoice could have an action called as send email. So the list can be arbitrary. What we are now saying is that you should look at this scenario as a subject trying to access a resource, and what you are doing in your code is just marking a resource. So when you use an annotation, for example, @secured, you basically specify what resource and what action is this piece of code performing, and leave the rest of decision making and enforcement to a piece of code that will be outside this. So how will it work? So what we are saying is that subject is performing an action on a resource, and resource, let's say, lives inside a resource server. We can have few points which we are calling them as enforcement point, which intercept a particular access, and they refer that the access to an OGG component which will make a decision on whether the access is allowed or not. And if access is allowed, then the access is granted to the resource. Now that's a simple use case. Sometimes you may allow access with certain modification. Sometimes you might say that I may not let you look at the complete representation of the resource, but only a part of it. So all that can also be handled. But the whole idea is that we have an enforcement point which intercepts the request and then passes it to another decision-making body, which is OSI component here. If you would have looked at, if you remember the previous example, we had an annotation. The interception of that annotation could be the enforcement point, and depending on, for example, if you're using Spring, you could use Spring's mechanisms to intercept and enforce access control. Now, again, going back to what a resource could be, it could be a table, a database, it could be a row inside a table, it could be a message, it could be a folder, or it could be a file, it could be a piece of functionality, it could be a queue taking messages or messages themselves, it could be an API, a RESTful, SOAP, etc., or it could be a GraphQL entity. So you could say that this particular type or this particular field of the type of the GraphQL entity is being protected. Or it could even be a UI piece of functionality, for example, widgets. So one could say that a particular widget is only available to a particular set of users. So the idea here is that resource could be anything, and what we are interested in is just the action that can be, the name of the resource and the action that can be performed on the resource from OSI's point of view. Interception is very specific to the type of resource. So if you have a UI resource, a widget, you would be intercepting something inside the UI code. So this is an abstraction where we are saying that abstract all these things as a resource and mark them as resource in the programming language or platform specific way. This idea is not new. This is how I think the web was built. And if you look at the RESTful view of the world, of the web, you would see that at the center of it is resource. And when you type a URL in the browser, you are basically typing the location of a resource. And what you get back is a representation. If you do a read, and you can even update that representation. So this resource, as we know in the web, right? HTML, a resource can be an HTML, could be an HTML page, it could be a file, it could be JSON, it could be many things, and it is all abstracted out as a resource as far as the protocols of web are concerned. And we also know that on a resource you can do actions. Usually they are CRUD, and you have different HTTP verbs that are mapped to those actions. We are also using the similar model of defining a resource and actions, but doesn't have to be tied to web's view of resources. Now, this is quickly, if you are using Java code on the server side, you could use annotations. If you are using React, they're coming up with a new mechanism called as decorators, which look very much like annotations. GraphQL has a notion of directives, and even in places where you have a different programming language, you could declaratively mark resources inside YAML. For example, if you have a REST API, you could mark them inside the YAML, and there could be a common interception code that can intercept access to those resources. Okay, so probably the last thing on resources before we move on. We also would need a way to group resources into higher level resources, because when we are talking about Java methods or we are talking about UI components, these are too low level set of resources. for user management. So if you define roles in terms of these very low level resources, your roles will start having just too many permissions. So what we want to do is we want an ability to club resources into higher level resources. For example, you might say that I have a resource called invoice, which translates into few Java methods, which also translates into a widget that gets shown on a particular screen, and some API, and all that can be clubbed inside a resource called as, for example, invoice, and you might name it like that. So we need some way of grouping the resources before the resources are available to be mapped to roles. They can be same or different from RESTful resources. Remember that these resources are only for authorization. The type and manifestations of this are not important for user management. And also that because we have created this abstraction of resource, we have homogenized access control across different platforms, languages, and systems. So when in identity system we talk about resource, it gives a homogeneous treatment to different things. Now, we have defined resource and action, and we have said that in your code, map resources and actions, and then just leave it there. Do not make any other decision in your code. What we are now saying is that outside of it, there would be a place where roles can be defined in terms of resources and actions. And we are saying that a subject is assigned a role. Okay, and roles could even be company specific. So if in an invoice app there are you sign up and you have your own company there with multiple set of users, you can go and define your own roles and assign your users those roles, and roles can be grouped inside other roles, and that way you can create higher level roles, and it makes your user management really easy. So this is the core domain model of Auerbach. If going back a little bit in the history, Auerbach was basically defined as a standard by NIST in 2000, the first version of it. And this was the model that was presented, which is very similar to what we have seen. Basically, it talks about objects, which are resources, operations, which are actions, and permissions are basically the tuple between objects and operations here. And these permissions are assigned to roles. Roles can be in role hierarchy, and users are assigned roles. There is also a notion of session in the core Auerbach model. And the idea here is that you can, in certain sessions, you can activate certain roles, and based on that, you can only those permissions are available. So even though as a user you have multiple roles, you can choose to activate only few of them and then work based on that. This is similar to you looking at a Google document as a read-only, in a read-only mode, and then later switching to, let's say, edit mode. So you could choose the role that you want to be activated. But it's the same model. Now, just to put this thing in perspective, what happens is subject comes, logs in, provides the evidence of identity is proven, and then subject performs an action on the resource. Resource server, at the resource server, this access is intercepted, and auth is called into play. Auth fetches roles and transitively all the permissions, and it basically does a simple, in the Auerbach model, it does a simple check to see if this permission exists, if user is allowed or subject is allowed to access this resource for this action. If yes, access is allowed. If no, it is failed and an error is returned to the end user. So what we have done till now is we have separated the concerns. We said, annotate, when you build your product code, you just annotate your product code with resources and actions, and do not worry about enforcement of it. Then what we said that, depending on platform, for example, if it is Spring, you would write an interceptor which will intercept and enforce access control. So this is specific to that. Now for enforcement, you need to delegate it to a decision component, which we are showing, which we have said that keep it separate, and we'll come to that in a moment, why it should be separate. But there is a separate component that makes the decision, and based on the decision, the enforcement is done. And what we have also said is that managing roles, assigning users roles, and the definition of roles, all that can be outside of the complete product code. It can be centralized, and you can define new roles as and when you want. So we have actually separated concerns, which is nice thing, and you will see in a moment the other benefits we get of this. So let's come to a point where permissions, where RBAC becomes slightly deficient. So let's say I want to give permission to some user between 9 a.m. and 5 p.m. So I mean, one way to think about it in Auerbach model is to assign a role at that time and then unassign. So that's one way to do it. You can quickly see that as such use cases increase, it becomes more and more complicated to do it in this way. The other example that we said was that if an expert is assigned to work on a case, and because of that case has to access your data, you will have to again in RBAC world, you will have to assign the role during the case time and then close it once case closed, and it all becomes complicated. And we also talked about customer support use case, where when somebody calls and the support agent needs access to the data for that session, we need to provide dynamic access. So these, and there are some more use cases where you probably want to apply complex temporal roles, temporal decisions to allow access to a particular resource. So what we are saying in picture form is this, that there are use cases where the users to role mapping is changing frequently, and you could have a human or certain automated process that do it, but this is all error prone and clumsy. And why is this happening? Because we are assigning users to the roles, and we are not actually looking at the attributes of the users and some other pieces of information to make the decision. And that's where the ABAC part of our session comes. So what we are saying is that instead of looking at just the subject and the roles that are assigned to that subject, let us look at some more pieces of information. And we're calling them as attributes. So we look at these pieces of information, and this, how we look at those, is also defined by the developer of the resource or the owner of the resource, and we call that as policy. And we'll look at a sample policy, but for now, think of policy as some logic that looks at the attributes and other pieces of information and makes a decision whether access should be granted or not. So what we have done now is that we have made this decision-making process dynamic. So now once again, what happens, going back to our original diagram of RBAC, we are basically saying that subject is trying to perform an action on the resource inside resource server. The request is intercepted based on the enforcement point. So nothing has changed in the product code that you wrote, but what now has come in, enforcement point has come in, but the decision making process has changed. Instead of just looking at roles, we are now looking at a policy, and letting the policy decide. A more concrete example, so let's say there is a subject who's a manager, sales manager, is trying to read one of the salesperson's data. Here what we are saying is that there is information about the subject, which is that this person is manager, which can be specified using a role. There is an action that is being performed, which is the read, on a resource, which is employees data here. And there are environmental attributes like time of the day, threat level, risk associated with this call, the product or the SKU of the product, etc. All these pieces of information are given to the policy, and policy basically decides whether the access should be given or not. If policy says yes, the attribute based access control says allow, or else it says deny. Attribute based access control is actually, this is sometimes called as PBAC, which is policy based access control. When I say ABAC, I mean PBAC is also included. So we are talking about a system where a lot more attributes, lot more pieces of information are taken in, and also a policy is relied upon to make decisions. Now, how does a policy look like? Here is an example. We don't want to get into the language or the content of this, but the idea here is that it basically specifies conditions. So there are listed predicates, and when they all are true, then an access is given. So you can write many rules, and you can write predicates inside it, and which test different attributes and make a decision. This particular policy is written in a language called as Rego, and it's used by Open Policy Agent, which is one of the open source and very popular policy based engine that a lot of products use for ABAC. Okay, so what we have said till now as far as ABAC goes, we have said that there is a lot more information that is fed in, and we call that information as attributes, which are basically key value pairs. And we group those attributes inside 4 kind of entities: subject, resource, action, and environment. These are passed by the caller most of the times, but they could be fetched by the system also. And we have a policy that is written in terms of these attributes, and all this goes inside the authorization decision making process, and out comes the answer yes or no. So this is the state of art that a lot of products companies are using to implement complex access control. Okay, so one thing that I would like to mention here is that for all this to work, we should not be enumerating permissions. So we should not write code which says that get me all permissions. Instead, we should basically assert the action that is being performed on the resource. So we should ask a question to ABAC saying that subject is trying to perform an action on a resource, should it be allowed or not, instead of enumerating all the permissions. And if you do that, if you make assertions, then your decision making process is pretty flexible. It can use RBAC or ABAC depending on the condition. Here is the same thing in different form. So what we are saying is that the framing is that subject S can perform an action A on resource R, and all of these are basically attributes. It's a very generic unstructured model, so you can pass any attribute and it can handle many use cases as long as policy is written in terms of the right attributes. And at runtime, what happens is a request comes in. At times the policy needs some more attributes, and we use a process called as attribute resolution to fetch more attributes, pass all the attributes that are in the request and fetched using attribute resolution into policy. Policy makes a decision and gives a permit or deny output. one more thing that policy can do sometimes is it can create an obligation, which is again a set of attributes. It's a request to ABAC system or the consumer to do something. For example, create an audit record or send an email of an improper access, etc. So this is probably the last slide where we want to just summarize the ABAC and use standard terminology. So this is the XACML terminology, and it's a nice way to talk about the components of authorization. At runtime, a request comes, it is intercepted at a point which is called as policy enforcement point. It could be gateway or the server before the resource is accessed. This policy information point passes the request to a decision point, which could be a service somewhere running, or it could be a component running together in the same process as PEP. This is called as policy decision point. Policy decision point might need more attributes, so it goes and fetches it from other systems, which are called as PIP, policy information point. And it also needs policy, which it fetches from a system which manages policy, and it's called as policy administration point, where the author at design time go and create policies and manage policies there. So this is the standard terminology of XACML. So what we have done, to summarize, we introduced AuthZ. We looked at the demands of AuthZ in the modern world. We said that we should take a resource-centric view when we are writing code or developing features. And then we talked about RBAC and ABAC as two models that can be used to make access control decisions. So I am now open for questions, and please feel free to even email me after this session, and this is my email ID. We can get to questions.
I see the first question.
Okay. Yeah, so the one question we have is, we are not quite clear why role-based auth won't work well with user-defined roles. So the problem is this. Okay, so user, let's say, problem is not with RBAC, but problem is the way code is written. So if you write your product code and you say that you have, let's say, 3 roles, admin, employee, and sales manager, and you have shipped your code, it's deployed, etc., it's all running fine. Now you want to give your end user a functionality to create a role. So end user basically creates a role called as, my best salesman or supervisor, let's say, or creates a role called as supervisor. This role is created at runtime. Your code cannot use that role to basically enforce, because it's a runtime, it's user entered data, it is created at runtime. Your code obviously cannot know it. At least you can't put it inside your annotations. So that's the idea of that, we should not use roles inside the code, but we should rely on defining resources and actions, and leaving it there, leaving the rest part to system outside of product code.
I asked Bala, this is Manish here. As another question, it has come as an answer to Aya's question. How can ABAC and RBAC work together?
Yeah, so I think this is one more interesting thing we did. So we said that let's separate concerns. So we said the decision, keep it outside. Okay, so by making decision outside, we can bring ABAC, RBAC, and if there are other models of access control, we could bring those also. Now, the way to merge RBAC and ABAC, there are multiple strategies. My preferred strategy would be to use role as an attribute of subject. So role is one piece of information that goes inside the decision-making process of ABAC. It's just one attribute of subject. And policy should be written in terms of, it should look at role, and it definitely, it will probably look at something more also, but it could look at role as an attribute of the subject and make a decision based on that. In that way, ABAC and RBAC can work together. Okay. Yeah, so another question that has come is, how do we manage latency overhead or resiliency of OZ? So if we make these decisions often, and we have to make out of process calls, it all adds to the latency for that particular request. The way a lot of systems today do is that they try to make decisions locally. So let me show the diagram, and that will probably help. So what we are basically saying is that many times the PEP and PDP is in the same server that resource is. And PDP then just becomes, PDP and PEP just become method calls inside the server. These need not be remote. It is also true that not in all use cases you would be able to do such a thing. A local, we call it as local PDP. Sometimes you have to make a remote call, but hopefully though that will be 10% of your use cases, and 90% of your use cases you can make the authorization decision locally, where the data is fetched and kept cached, and the decision can be made locally. So that basically that improves the latency, because it is now a simple method call. It will take only microseconds, and it also improves the resilience, because you are not dependent on another remote service call, the resiliency of your service doesn't degrade.
Okay, thank you all. I don't see any more questions. Feel free to write down to Bala if you have any more questions, and we will also share the recording of this session to all of you. With this, let me close this webinar. Thank you very much to all of you for joining this webinar.
Thank you all, and thank you, Manish.